Okay, so now Paweł Łabaj will briefly summarize and look at the perspective possibilities of the metagenomics challenge.
Okay, good afternoon, everybody. So I'm going to talk a bit about from where the metagenomic challenge comes from and how maybe it can develop further. So the first time when metagenomic, this topic from Metasap appeared at the CAMDA was in fact in 2016 in Orlando, when Ibrahim Afishneko from Chris Mason Lab was talking about their newly published papers, what they have found in the New York Metro in terms of the microbiome. And then after the end of this session, the CAMDA friend, Wei Datong, has asked, okay, it's really cool data, but what is your goal? Why you are going to collect this data? Where it will lead? And it was a very good question, because at that time we had no idea really. It was more about gathering the data and start exploration, what we can see there. But because in fact we don't know what is around us. We know that there is exposome, that there are plenty microbes living around us, but we have totally no idea how they are affecting our life and what's happening. People are saying that they probably are good. As we have heard yesterday, it's better to not make everything clean too much because it's just putting pressure on microbes and it's making that they can develop the resistance. And in fact, we should treat that the microbes are living on us. They are like a field force which are protecting from the bad ones from the environment. They are even ones which are saying that dirt is good. So we should really think about this, what is good, what is bad for us. And like Chris is saying that he would advise any new parent to roll their child on the floor of the New York subway because this is the best vaccination which you can provide to your kid. So this is what, let's say, came out from this digging into the data and trying to see what's there. And the concept of looking into the metro is that as a dense population, the cities, we see that like over half of the world population is in the city. In case of EU, it's almost 80%. So it's very important to know what's happening there in terms of the metagenomics, and we would like to investigate it because it affects our health and well-being. And what came out from the studies in New York that in fact for half of the stuff we have totally no idea what's there. And it was found at the time that this is more like a skin, but as we have heard yesterday, no soil, no skin, it's just some unique set. But we are investigating it further, like in New York it was found that depending on the district, the variety is different. But there were some basic estimation and the first results, and just from one city. That's why there was a concept to start collecting this data in many more cities, and this is how Metasap has started. At the moment it's around 70 cities all over the world where we are collecting the data. So once we became more massive data, there was a concept, okay, maybe it might be a good challenge for CAMDA. Yeah, critical assessment of massive data analysis. And this is how we have started. So in 2017, we have provided 3 US cities, the data from US cities, just as exploratory analysis. And the question was more, okay, whether we can see something there, whether we can see a signal which can allow us to differentiate between these different cities. Then later in 2018, so last year, we have more cities, and also we already had some mystery samples. At that time, it was for classification. This was the main question, but also like looking into the future for the prediction of the sample origin. And in this year, we provided even more data, complementary data from 16S based, and this year the sole prediction, the question was a prediction. So after 2017, we found, or participants, they have found that yes, there is a signal out there, and it doesn't matter whether you're looking into the micro metagenome or macro metagenome. It just, you can differentiate cities between each other. And it has ended up, the study has ended up in the 4 papers, which are already for more than a year out, so they are freely available on the Biology Direct. In terms of the 2018 challenge, we could say that yes, there is a high accuracy of classification, but not prediction. And it doesn't matter which approach people were applying. Either it was a taxonomy species-based, so like it's more coming from the structural and ecological perspective, or is it more functional biochemistry-centric, or maybe just pure data-centric. So we don't putting into any biological context, we're just looking solely to the data and trying to find some patterns. And from the last year, there are 2 manuscripts are already in production, and 4 manuscripts are accepted, so they will be also out soon. In addition, with the other colleagues from Metasub and experts from the forensic labs, we are preparing a manuscript which will be talking about the perspective in forensic microbiome intelligence. And we hope that this paper should be out till the end of the year. So what about this year? So as we have heard yesterday, still not enough data for accurate prediction. That there is a found higher predictive power for the geological coordinates, depending how we are looking into the data. So it's still not the level of, let's say, high resolution data and how much details we have to be able to predict really the new locations from the data. And in fact, as we have seen yesterday, even the prediction of the continent is a bit tricky. So what should we provide? And here, maybe I will not need wait for answer from you now, but we have the CAMDA forum on the Google forum where you can put your concepts. But I think for the next 1 to 2 months, I will be just collecting information, trying to think about how we can complement what we had so far. So looking from Metasub perspective, there are at the moment 4 tiers of the where the samples are. More than 4,000 samples have been already sequenced, and most of them they are creating a data set on which the main Metasub manuscript has been written, which David Danko has presented yesterday and which will go online soon. As you can see, there's more data which will be sequenced in the near future, and at some point they also can, they will become public and they can be included into the CAMDA challenge in the next releases. But of course, what was clear from what you have said yesterday is that we need to provide better and more metadata, which will allow us to study it with additional features, which might affect the current prediction. Because there is this limitation of the study, which was also highlighted yesterday, that about the longitude, that probably other coverage, metadata are needed. So yes, we are thinking about this, and it will be very valuable to get feedback, detailed feedback from you, so we can prepare better data for the next year. But the general concept for this prediction was originally based from the paper of our friend who was doing something similar, but for the SNPs, so predicting the person origin based on using admixture model based on the known locations of the specific people and their SNPs combination. And putting into the context of what we have, there can be many similarities, and we have seen that some people were trying to use something similar to this, but there are also some limitation. As it was shown on the previous slide, it was world is round, or maybe even world is a sphere. And if for us, going from one place to the other is not the problem, for microbes it is. We have to take into account all the natural barriers. Also, of course, this is, let's say, somehow bypassed by us, the bacteria traveling with us or bacteria traveling with the goods. But still, it's more difficult. Also, bacteria cannot live everywhere. It's limited to the defined ecological niches. And the characterization of such ecological niches has to be also taken into account. So in the paper by Hendriksen, it was defined like the 4 different, like say, spheres, like depending on the pH. So the pH cluster, high pH cluster, low pH cluster, dry lands, and the low productivity cluster. And if you will have a look, it sort of confirms the problem which you had when you were trying to predict the longitude and latitude. That in one case, it's easier because it's going north-south, and the other, it's spread all over the world. So your prediction problems might directly coming from existence of such ecological niches. So the concept will be here to add all these features to create, let's say, ecological niches area, and then trying maybe not at the beginning predict exact location, but maybe the possible ecological niche from where the sample is coming from. And then maybe in the second phase just to try to predict better where within probable locations based on the ecological niches the specific sample can come from. So these are just my thought how this can develop. And we'll open discussion on our Google forum just for you to contribute and give us feedback which direction we should go. And also from one of the paper from last year, so from 2018 challenge by Fergal Ryan. So this is what he said, and this is, let's say, also summarizing what I have said and what you already has noticed and presented yesterday. That there are additional factors, and we really need to take this climate effect or climate set of the features into account. Otherwise, we cannot really predict it accurately. Another idea for how CAMDA can develop further, it will be the investigation of antimicrobial resistance markers. We see from the function analysis that we can observe them in the current meta-sub data. And as David was also outlining yesterday, we also had made the profile how it's looking in the different cities. But it will be interesting to see whether the markers or the set of the markers or the synteny of markers which we can see in the clinical isolates, they can also be traced and noticed in the real environment, the city environment. So we would like to go this direction, and at the moment I'm negotiating with one partner about releasing data from about 1,000 of isolates in terms of the whole genome, deep whole genome sequencing, plus the testing of the antimicrobial resistance on multiple drugs. So if it will succeed, then hopefully in 2021 we could just make such challenge as a part, or maybe as a direction to develop the Metasub data-based challenge. And as I have mentioned, if you will go to the Metasub CAMDA web pages and go to the About CAMDA, you will find information that we have a set of the forums where we are seeking for your feedback and participation in discussion how this should develop further. And one of them is dedicated for the metagenomics data analysis, so the Metasub forensic challenge. And in the next days, I will just open a thread waiting for your contribution, how we can improve the challenge by adding the data which you think might be very valuable, that they will be complementary, which will make this prediction really possible in the next round. And your suggestions about how this challenge, but also the other challenges in other threads, how they can develop in the near future. Because we are making the CAMDA for you, so to make you happy about the data which we are providing, that this is what you're looking for, because in many cases, after many talks, people are asking, okay, are these data available, or how we can get more data, because we have interesting tool and we would like to test it somewhere. And I think that the CAMDA is a really great opportunity where we provide data, but not the data which we want to provide, but rather which the community is looking for. To apply their tools and also to answer the questions which are at the moment pending. So this is everything what I wanted to say. Thank you for your patience and listening to me. I'm happy to talk also further about if you have already some kind of ideas. So I think we are ahead of schedule with the next part.
So are there actually any immediate questions that people would like to ask with regard to the metagenomics challenge?
it might take some time to digest what I have said and what people have seen over the last 2 days. But
Okay. There is a question, okay. You want to come here?
Hi, Paweł. It's just really exciting to see that you're potentially adding AMR.
Can you speak
on
a
it.
bit louder?
It's very It's very nice to see that you're planning to have the AMR data sets on it. So in terms of the annotation or whatever it is you found in the sample, are you going to target specific antibiotic resistance, or because there's just so much information, like one could be more resistant to different antibiotics? Like,
So in terms of this AMR possible change, we are investigating what might be interesting and what might be doable. So
yeah.
what I hope we will get, as I have said, it will be this that clinical isolate which were collected all over the world, with some already input provided by this partner. And then we hope that combined analysis with the environmental data from Metasub, but also from other, might provide some additional understanding how this is spreading, or whether there's for specific, let's say, resistance markers or appearing of resistance, specific conditions are needed. Because maybe this resistance can just appear in human, but when then transmitted to environment, it can just disappear. So you might see part of the resistance, few markers, but not all of them. We just don't know this, yeah, because you have like, there is like World Health Organization GLASS initiative, but it's mostly towards synchronization and standardization response and the procedures within hospitals, how hospitals are reacting. But we need to start thinking that this resistance can arise already in the environment and then transmit to the human. So we would like to know how it's going and try to react faster.